Thiemann has worked for watershed councils for over 20 years, implementing small and large-scale habitat restoration projects, running watershed monitoring programs, and more recently, leading the Hood River Watershed Group. She holds a master's in biology from the University of Oregon with a secondary master's in community and regional planning. While at the university, she was a graduate teaching fellow for limnology, freshwater biology, and plant physiology courses. When she's not working, she spends her time gardening, hiking, and playing with her husband and 2 kids. And she has hiked the Pacific Crest Trail twice. Okay, so Cindy, take her away.
All right. Thank you guys for joining us and me for on a lovely summer evening. It's fun, you know, it's been a while since we started this action plan process, and let's see, hold on a second. I just need to rearrange my view so that I don't block my own slideshow from so I can see my own slideshow. So it's been a while since we've started this process, and Jordan, I was looking through the meeting minutes so towards the beginning of 2018, and your name showed up a lot in the meeting minutes. So that is a little bit of a, you know, bracket of when we started this. So it has been a little over 3 years that we've been working on this, and it's been an effort by all of the partners here listed on this page: the Confederated Tribes of the Warm Springs, Department of Fish and Wildlife, the 3 major irrigation districts, Soil and Water Conservation District, the Watershed Group, Forest Service, Department of Environmental Quality, Columbia Land Trust, Natural Resource Conservation Service, and Hood River County. Everybody has contributed in one way or another to the Watershed Partnership, and a lot of folks have put in many hours on this Watershed Action Plan. So thank you for coming this evening, and thank you for all of your efforts. So I have about a little over 30 slides. So some slides I will go through rather quickly. Other slides we'll spend a little bit more time on, but I did try to provide a mix of information. So I didn't assume that everybody was intimately familiar with the watershed, but there is plenty of detail for those of you, for many of you on this attending this evening, that you'll be able to kind of appreciate and dig into. So we did receive Oregon Watershed Enhancement Board funding to develop this action plan, the strategic action plan. It's focused on aquatic habitat for native fish species. And the requirements for the plan evolved so that the strategic action plan that's developed will have the components that are consistent with the focused investment partnership funding opportunity. And I also think that it's been a very good, I think that the OWEB did a good job of building a template for a strategic action plan that even if a partnership doesn't end up getting focused investment partnership funding, it's still a worthwhile endeavor. We also had the opportunity to work with Bonneville Power Administration through our through the connection with the Warm Springs tribe, and we used their Atlas restoration prioritization matrix framework. So BPA provided some technical assistance, and that framework, which I'll share a little bit into the presentation, informs sub-basin ranking and in-stream habitat restoration project prioritization largely. So we're going to go through chronologically. So when we first started this process, we looked at, we actually, a small group of us had been working on a vision statement for the Watershed group. And this is what the group had come up with, and had been adopted by the Watershed group, I think several months beforehand. And everybody, all the partners in the partnership felt like this was a vision that could work for the partnership as a vision statement for the plan. So that is that the Hood River Basin Partnership envisions a resilient landscape that supports native fish and wildlife, a community willing to protect and restore its natural resources, and a local economy that thrives within the natural systems of the watershed. And I think, and it was amazing how long you could spend on a single sentence, but it was several meetings to get to wordsmith it. And I think that what's nice about this statement is that it reflects, it has a lot built into it. So we want that resiliency. We want to be able to support native fish and wildlife. A community willing to protect and restore its natural resources also speaks to a community that understands what it needs to do to protect and keep our natural resources resilient. And then a local economy that thrives within the capacity that the watershed can provide. And I think that Hood River County and the communities within it are, I think they're well on their way to to being in stride with what the watershed can provide. Although it is something that always will take awareness. So healthy aquatic ecosystems are essential to the strength of our community and economy. This plan is really centered around aquatic habitat for native fish. But a good reason for that is that native fish are central to the structure and function of aquatic ecosystems. So they do serve as good indicators of aquatic habitats. So all of these things that support, that support our livelihood, and the incredible drinking water we have here. We have, probably close to a dozen breweries and distilleries, and companies that make use of the high water quality here, in addition to the fruit that's produced. So just a few highlights about the watershed, since most of you know the watershed well. For those of you who are less familiar, just some highlights. It's a very steep watershed, and that has ramifications for the habitat restoration work we're able to do, and a habitat that's really possible for the watershed. That means that there's a scarcity of pools and also a scarcity of broad floodplains. The glaciers on the mountain influence quite a few of the streams. They increase turbidity during parts of the year. And then there are semi-frequent debris flows. And I'm pretty sure that this picture was of the 2006 debris flow. I borrowed it from Les's presentation from his a couple of years ago. So pretty sure that was 2006, but yeah, it's there can be destructive events along these streams. It's a really forested watershed. 80% of the watershed is covered by forest. 50% is Forest Service land, 30% county and private timber and unmanaged woodlands. Agriculture is really important to the economy and the culture. But I found it interesting to also note that other industries are growing. And you can see this is a figure that came from our water bank feasibility study that was completed a couple of years ago. And one of the, some of the consultants that did that project are economists, where one of them is an economist. And so they presented major industries in the watershed and taking a look at annual earnings. And so you can see that Farm earnings are down here, this kind of light blue or royal blue. At least it looks like that on my screen, but can you guys see my cursor okay? Yep, okay. So anyway, farm earnings have been steady. They've increased some, but interestingly, when you kind of look back, you know, I look at manufacturing here, which was, you know, kind of a little bit above farm earnings back in 2001. And, you know, it's had some volatility, but it's, you know, it's gone up quite a bit. So there are, I think, other growing industries to take note of. Some may or may not have much of a, you know, impact on the natural resources of the watershed, but it's something that I'm curious about, and I think it's good to note and kind of keep thinking about how to engage a broader cross-section of our community. Irrigated agriculture does cover 10% of the watershed. And not surprisingly for most of you, it has relatively large, given the footprint, share of water use in the basin. So this graph is showing the cubic feet per second of two different things. So this gray line is the river itself, the Hood River itself at Tucker Bridge. So kind of several miles up from the mouth. And you can see in October, it's running around, you know, in the 500 CFS, pops up to, you know, 1500 CFS or 1500 CFS in January on average. So this is average. And then, you know, drops down to like 400 CFS at Tucker later in the summer. And you can see the orange line here is irrigation. So that is when, you know, sort of in the prime of the summer, drawing collectively from all of the irrigation districts, a little over 200 CFS. And then blue line down here is domestic use. Now, it looks like it's zero, but it's just because the scale is, of course, the way it is. But it's a lot less. It's about 20 times less than what agriculture uses for in terms of water. Sorry, I'm trying to, let's see. I think I'm just going to hide the thumbnail. There we go. Other watershed highlights, the Confederated Tribes of the Warm Springs maintain their rights to harvest fish and game and other foods in their usual and accustomed places in the watershed. So in other words, the watershed is ceded lands for the tribes. And fishing opportunity has become pretty severely restricted for the tribes. And so they have a pretty significant presence in the watershed and are an important partner and a really active partner in habitat restoration and taking steps to improve fish harvest as well. So the Hood River watershed has one of the most diverse assemblages of native fish in Oregon. There's both spring and fall Chinook, winter and summer steelhead, coho, bull trout, Pacific lamprey, cutthroat trout, and several other native resident species. And you know, the reason is because of where we are, where the watershed is located relative to you know, the position on the Columbia. So there's both sort of west side and east side species. And so winter steelhead you find more to, you know, are to the west, summer steelhead are to the east of us, but the Hood River has both of them. Although in this case, winter steelhead are the stronger run. They have the greater number in the watershed. And I should have said, please feel free, if you do have any comments or questions, you can note them in the chat box. If there's not very many of us. So if there's something that, you want to ask midstream, I'm okay with that. I think we have enough time for that. So here you'll see maps of distribution of the fish species in the watershed. Over here on the left is salmon and steelhead, spring and fall Chinook salmon and steelhead and coho. And you'll see that, let's see, so the orange line is, sorry guys, I am having this issue with these bars getting in the way of my, getting in my way. So summer steelhead, the significant thing to note is it is mostly found in the West Fork, whereas winter steelhead is mostly found on the east and sort of the middle parts of the watershed. So Middle Fork and the East Fork, Neal Creek. Coho is mostly down in the main stem, Neal Creek, and potentially to some extent up the lower East Fork. Fall Chinook is mostly along the main stem. Fall Chinook, even though it shows the distribution, well, it's kind of hard to tell because of these overlapping lines, but ODF&W I've had a lot of ODF&W biologists and tribal biologists who, have noted that fall Chinook just don't make it that far up the river. So then over here, we've got bull trout and Pacific lamprey distribution. As a lot of you know, lamprey are moving more farther and farther up the watershed each year, it seems. And so that's the pink line. They've made their way up into all of the main branches so far of the Hood River. So that's been pretty fun, I think, for all of us to see them, getting farther into the basin. And then bull trout, really the population, the population is within the Middle Fork watershed, although the West Fork is designated critical habitat. So perhaps one day bull trout could make use of the West Fork. So a little on historical impacts, and I also borrowed these photos liberally from Les Perkins' presentation that we did together at Sense of Place a couple of years ago. And I think he stole them from Arthur Babbitt's, who has a trove of these really cool historical photos of the watershed from the Historical Society. So the point here with these pictures is that timber removal, timber harvest, and significant channel alteration on the main stem of the Hood River, particularly, and in the tributaries still has effects today. You can see this upper left photo. This is what many of you know happened, where they harvested trees and kegged them up in the stream, and then dammed it and released the water, released a dam, and they all went swooshing down to these these log ponds. This is a flume. So they also built flumes, and this is the mill at D many years ago. This is the original Powerdale Dam. Before it was constructed in the early 1900s, it had a location that was farther up the river that lasted, I don't know, 5 or 10 years, and then they relocated it to where it was up until 2010. And then this is an early, I don't know which canal this was, but the size of it looks like kind of the main canal, but I don't know, John, if you recognize that. But yeah, so irrigation canals were part of the landscape. They were, starting to be excavated in the late 1800s, and well on their way to, sort of to many acres being irrigated by the early 1900s. So conservation need that brings us to where we are today. Bull trout were listed as threatened in 1998, and steelhead, chinook, and coho were listed in 98 and 99 and 2005, respectively. And bull trout, their listing is throughout their range. And then I'm sure steelhead, chinook, and coho are listed elsewhere, maybe less listed elsewhere, but these listings are really for the lower Columbia River distinct population segment. So the overarching goal of the action plan is that by 2040, and keep in mind, this is a lofty goal, conditions in the Hood River watershed will support viable populations of salmon, steelhead, bull trout, Pacific lamprey, and other native fish. And this really includes sufficient water quantity, water quality, connectivity, and habitat diversity and complexity to support each stage of their lives in freshwater. And I think, I did make a distinct effort in this plan to make that connection between what we need to provide habitat-wise for the different life stages. And I thought it was worth just reviewing these life stages and noting the different habitat requirements for these different life stages. So, you know, adults are returning to spawn in fresh water. And there's variability in the species that we have returning from the watershed in how they approach this. So for example, spring chinook show up in the spring and they need to hang out in deep pools all summer before they spawn in August and September. In contrast to winter steelhead that show up, you know, at some point in the winter and, you know, spawn, maybe they're hang out a little bit, but they're not holding in the same way that spring chinook do. So winter steelheads spawn relatively soon after they arrive in the watershed. And then in contrast, summer steelhead show up and hang out for almost a year in the watershed before spawning. And so you can really think about, well, what kind of habitat do each of those returning adult need to be able to then spawn successfully. Reds, so you know, the fish that spawn in late summer and early fall, like spring chinook and coho, are more vulnerable to having their reds scoured away by volatile winter flows. So that's another sort of life history challenge for them, and a consideration for habitat restoration as well. Once they, you know, get out of hatch and are make it to fry stage and then par stage, they've got a lot of time in the watershed before they migrate back to the ocean as adults, and that varies as well. So spring chinook and coho have, you know, well, actually coho leave fairly quickly, so they don't hang around that long. Chinook will hang around for about a year. Steelhead, on average, they stay here 2 years, sometimes even 3 and 4 years. So when we think about the different velocities and structure that each life stage needs, it makes sense that we need to offer a lot of habitat complexity. Uh-oh, sorry about the barking dog. So, all right, sorry about that. This brings us to thinking about those primary limiting factors and what the threats are to create those primary limiting factors. And we had 4 of them. So reduced in-stream habitat quantity and reduced in-stream habitat quality, which includes access to off-channel habitat. So threats that could lead to that reduced in-stream habitat quantity and quality are reduced stream flows that is contributed to from climate change, and also irrigation, hydropower, and municipal diversions, buildings and roads in floodplains, fish passage barriers, timber harvest practices, diminished or altered riparian vegetation from various land use practices, loss of beaver dams, altered hydrology from road network or development in the floodplains, dams, and also climate change. The third and fourth primary limiting factors are sediment load impacts on stream habitat and water quality, in particular, elevated pesticide levels and summer water temperatures. Sediment load, no doubt the biggest impact is the glacial influence, and many people have noted that those impacts from the retreating glaciers and the change in climate will likely have, we'll start to see more impacts of that sediment load. To perhaps a lesser extent, timber harvest on steep slopes and road management and location also have a sediment impact. And those are things that we have a little bit more control over. At least locally, we have more control over it. Water quality, the partners over the past 20 years have done a remarkable job of reducing pesticide levels in streams. It was, I believe the Hood River was the first pesticide stewardship partnership in the state. And so we have this, but I think it's important to note that really big strides have been made in improving pesticide levels in streams, but it is important to kind of keep, stay aware and keep monitoring that because pesticides are definitely an aspect of having a lot of orchards in the watershed. But threats, sort of contributing factors to that: diminished riparian buffers, chemical use, really not just from orchards, but forest practices and rural residential land. And lack of BMP, best management practices during pesticide application can also be, can be a concern. So next we're moving into, what I'll do is we'll look at these, those were the primary limiting factors in contributing threats. And I want to break down the goals and the strategies by by the topic. So we'll kind of go, I'll share with you some of the goals and dive deeper into water conservation, and then we'll go on to stream habitat restoration next. So water conservation goals: by 2040, average monthly summer stream flows below irrigation diversions will remain at current levels or increase. So I think that is a feasible goal. It's aspirational, but I do think it's feasible. And this will be supported by piping all remaining canals and eliminating end spills in the East Fork Irrigation District, providing cost share to upgrade approximately 8,000 acres of on-farm irrigation, and promoting irrigation water management. And then this is one that we haven't really delved into before, but I think it's an important aspect and really is part of the community engagement piece and engaging a broader cross-section of our community. And that is, by 2040, the per capita rate of municipal and residential water use will have decreased from current levels. And so while our population will no doubt grow here, I think that there's clear evidence from other places that have implemented water conservation for residential land that we can reduce from where we are now in terms of the rate we're using it at. So this is a handy table to think about how much water conservation is possible. And I think, this information came it's coming from a number of sources. The water conservation strategy that Nicholas Christensen did back in 2013 or so contributed to some of these numbers. Work that the Farmers Conservation Alliance did with East Fork Irrigation District also contributes to these numbers. Other work that Ed Salmonin with Watershed Professionals Network has completed, has contributed to like the voluntary fallowing of for a water bank. So on-farm irrigation, top of the list, total potential savings of about 34 CFS. And where this is coming from is that 12,000 acres it is estimated out of the 20,000 or so acres, 25,000 acres of irrigated agriculture in the valley. The irrigation districts during when Nicholas was doing the water conservation assessment, each irrigation district manager estimated how many acres were still needed upgrading. And at that point, it was about 12,000 acres. So 6 or 7 years ago. So it's changed a little bit since then. I proposed, that what was most likely in the next 20 years was 8,000 acres, which is a tall order. So that is a very aggressive conversion. It's 400 acres a year for the next 20 years. I think I'm doing the math right. I might not be. Yeah, anyway, somebody correct me if I just did my math wrong, but conveyance system upgrades. This is the East Fork Irrigation District piping projects, taking canals and putting them into pipelines. Hydropower rebalancing comes from the Middle Fork and the Farmers Irrigation District hydropower projects, and it would come from generating about 5 CFS for Middle Fork and Farmers, generating about 5 CFS more in the winter and 5 CFS less in the summer. And so the cost to the districts would, in theory, be there wouldn't be a loss of revenue, but it would be better for streams in the summer. I'm going to talk a little bit about the water bank feasibility study in a second, and then I have added residential water conservation in looking back at Nicholas's report. And the amount of residential water that gets served by East Fork and East Fork and Farmers Irrigation District delivers quite a bit of water to residential lots. And so there's a lot of potential actually for residential water conservation. And that's not something that we have really delved into before. And I think it's something we do need to do in the future. When I first started 8 years ago, I think this was the first irrigation upgrade project that I got to visit. It was on Lenz Creek, and it was a project that the Soil and Water Conservation District had partnered, and maybe it was Natural Resource Conservation Service as well. It partnered with these farmers to upgrade 10 acres. They upgraded their sprinkler system. They also used soil moisture sensors. So prior to the upgrade, they were using about 1 million gallons a summer on a 10-acre block. Afterwards, they were using 374,000 gallons per summer. And other benefits was that their labor cost was reduced by over 2,000 a year. They had improved fruit quality, and they eliminated erosion caused by overwatering. So I really like this story. It's a, it's a nice, succinct, description of what great bang for the buck you get from these on-farm water conservation projects. So it's no surprise that they are a really important aspect of this action plan. So water banking would be a new endeavor. It is something that's happening around the West, particularly in the drier parts of the West. And we had a company called AMP Insights based out of Bend that probably has set up most of the water banks around the West. They did a feasibility study for us. And essentially it would operate in dry years or drought years. And it would be irrigating from people who, are growing, irrigating hay or perhaps alfalfa, and leasing from them so that they would forego all or part of their irrigation for the summer. And that would temporarily go in stream. AMP Insights they targeted 5,000 acres. There's somewhere between, 4,500 and 8,000 acres of grass that looks like it's being irrigated. And so they picked a sort of a number in the middle and cross-checked it with, made sure that it was actually grass that had water rights. So 5,000 acres was what they targeted, and they looked at a minimum of, you have to have at least 5 acres in order to sign up. And so, that'll enable them to see how much water conservation you'd be able to achieve if you had a certain percentage enroll in the program. And we also did a survey as part of this study to gauge interest. We had pretty good response. We sent it out to, I believe, 200 people who had at least 5 acres of pasture, and we knew that they had the pasture. And I think we got 35 back, which they said, AMP Insights said is a pretty good response rate. And of those, 70% said yes or maybe to being interested in temporary lease of their water rights for various purposes, but most of them said for to protect in-stream flow for that period, for that summer. So I wanted to, so this isn't totally as a result of, this graph isn't totally as a result of only the water bank. This is really looking at what is the effect of all this water conservation potentially on fish themselves. And like I was referring to several slides ago, the life history really changes what the interaction with stream flow. So the younger the younger the fish, the less tolerant it is of high velocities. So that makes sense. You're a small fry, and you can easily get washed downstream. And so this data is from what's called an in-stream flow incremental methodology study. And they go out and they measure cross sections, do cross sections of a given stream segment, and they measure velocity and they measure depth. And so weighted usable area, it is based on velocity and depth. That's really where it's coming from. And so they know, they have sort of accepted velocities and depths that are optimal for different fish species and life stages. And so they put that into one of these graphs, and then it depends on which stream you're at, how, what the curve is like. So in the case of Clear Branch, this is below Lawrence Lake Dam. You can see the effects of increasing stream flow. And just for reference, in September, the mean flow below Clear Branch Dam is 11.8 CFS. And so, you know, when you draw this line up, you see, and then you're looking at bull trout spawning, Chinook juvenile, sort of, you know, so bull trout are obviously, most people know they're smaller than Chinook. And so bull trout spawning, they start to peak out in terms of the cubic feet per second at lower velocities. Whereas Chinook, a much bigger fish, it really starts to peak, you know, it takes a lot more flow in Clear Branch for it to reach optimal spawning velocities and depth. So that's a species that needs more velocity and depth to be optimal for it to spawn. On the other hand, the juvenile life stage of Chinook, smaller, so it starts to, you know, habitat for its juvenile life stage, you know, starts to get optimal at a lower flow stage. But one thing I think that is important to note about this curve is that, with the exception of maybe bull trout spawning, they sort of peak and then they remain flat. So adding more flow isn't necessarily detrimental to these species. But, you know, when we look at, well, if we're able to increase flow on Clear Branch, you know, what does that do? It increases, and, you know, the species that are most common are bull trout and steelhead, I believe, you know, in Clear Branch. And so, you know, looking at, you know, steelhead spawning, you know, you could add a lot of flow and have it, and conditions keep getting better and better for steelhead spawning. Bull trout, you could, you know, maybe double the flow and reach optimal bull trout spawning on Clear Branch. On the other hand, when you look at the lower East Fork, the curve's kind of different. And what's really noticeable is that some of these really, you know, there's this downward trend. You know, different flow regime, obviously we're talking about here, the mean flow in the lower East Fork in the summer, like in August, is about 80 CFS. And you see that Chinook juvenile, at least according to this study, don't do as well, you know, in the summer, really probably at any time in, you know, the lower East Fork, because it's there's not a lot of protection from velocity in the lower East Fork. So you see that, you know, steelhead steelhead who are spawning, you know, early spring, you know, they're, you know, no doubt the East Fork, it, you know, could be optimal for them. Off the top of my head, I don't remember what the East Fork is like in the, you know, in springtime, but it's just noteworthy that, you know, when you think about adding flow in the lower East Fork, it is, you know, in the summertime, it is definitely better for Chinook and steelhead, but it may not be as great for juveniles. And I think the caveat is that there is not a lot of wood in the lower East Fork, because if you add wood, that does that affects velocities and depth. And so I really want to emphasize that I think that, you know, doing both habitat restoration and stream flow restoration are really important in some parts of the watershed, in particular on the lower East Fork. So overall, I think that things are somewhat optimistic in terms of our capacity to improve stream flow, conserve water, and you know, even in the face of climate change. So these graphs show you what it looks like. So these are future predicted stream flows without conservation and with all likely conservation, and also showing, so this black dashed line is stream flow during the summer at both of these sites on average historically, and historic for the purposes of this is 1980 to 2010. So the red line is what you might guess, it's the future if we don't do any new water conservation. So stream flows are going to get significantly lower from climate change. At least that's what is predicted from the climate models, and it's pretty consistent with what we're seeing, today in terms of a decrease. We're already seeing average decreases. Good news is, though, that with aggressive water conservation, like was outlined in that table, it does appear that we'll be able to kind of hold steady and maybe even be slightly above what we see now. And that would be a really good thing, because fish are, these anadromous species are currently flow limited, as we saw from the previous graphs. If we add more flow, habitat generally becomes more optimal in a lot of places. Okay, so switching to in-stream habitat restoration. By 2040, there will be enough habitat complexity and floodplain connectivity in the Hood River watershed to meet the life history needs of salmon, steelhead, bull trout, and lamprey. This will be supported by about 30 miles of stream channel restoration and reconnecting 20 miles of side channel habitat. By 2040, we'll have increased largewood recruitment potential in the basin. And this will be supported by protecting steep headwater areas from intensive timber harvest, and also managing for larger trees in high priority wood recruitment areas. By 2040, fish passage barriers with at least a quarter mile of high quality habitat upstream on anadromous streams are passable. And for resident fish barriers, what we're shooting for is if it has a half mile above. And I am sorry if you guys can hear background noise. Another goal that we need to work for is trying to develop screens that will not injure or kill juvenile fish. And in particular, what I know the irrigation districts, any place there is Pacific lamprey, are struggling with is developing a screen that doesn't pass the larval form. I'm not sure if that will, if that's mechanically feasible, but it's something that I know is being looked into right now. So continuing on with a few more goals relating to water quality and sediment load. And I think this is, well, so by 2040, summertime water temperatures will be closer to achieving state standards for salmon and steelhead, if not actually achieving them. This will be supported by increasing shade and summer stream flows on high priority stream reaches, as well as some flow management actions that are under negotiation right now at Clear Branch. So by 2040, pesticide concentrations in streams will remain at current levels or decrease. And by 2040, impact of forest roads on the magnitude and timing of winter stream flows will be decreasing. And this will be targeting things like improved road maintenance and road decommissioning on forest land. Okay, so big picture as to where to do this kind of stream restoration work. We are looking at intrinsic potential maps. And so intrinsic potential is the relative potential to support spawning and rearing habitat based on bankful width, channel gradient, and valley confinement. In gradient, I think everybody kind of understands the steepness, but also just how much room a stream has to spread out in its floodplain. And most of you know that there's a lot of confined sections of stream in the watershed, and that these maps really reflect that. So looking at the left is Chinook intrinsic potential, and high is blue dots, green is medium intrinsic potential, and then yellow is the low intrinsic potential. And so what really pops out for Chinook is that there's very little high intrinsic potential for spring Chinook in the watershed. There is medium intrinsic potential based on this geomorphology, and those are in some lower gradient parts of the watershed, and it echoes steelhead intrinsic potential. What really pops out to me on that map is 6 distinct areas that there's the central part of Neal Creek. Then that's Dan, that's kind of where you guys are living and downstream of where you are. There's a really large area in the lower East Fork, also in the upper East Fork, the lower Middle Fork, and Lake Branch, and also there's some in the upper West Fork as well. So this is a really important consideration, and I should say that the Warm Springs tribe funded most of the work. There was LIDAR data that was flown, I think back in 2008, thereabouts, and they were able to take this LIDAR data and make these intrinsic potential maps. And this work was done by Ed Selman as well. So keeping that in mind, we took it to the next level with the Atlas prioritization process. And just really briefly, don't worry about trying to look at really understanding these tables, but Atlas really drilled down and looked at what fish were where in the watershed. So this is the technical team spent several meetings, probably a dozen meetings, where we did things like identify which species and life stage was in which subwatershed. And I guess I should just point out that these subbasins, there are 9 subbasins, and these are the units, the subbasin units that we used in our Atlas planning. So we also prioritized what was the limiting life stage in each subwatershed, and the relative impact of aspects of those limiting factors. How much was it riparian condition? Was it, large wood recruitment, things like that? And also how much we thought different restoration actions would improve conditions in each subwatershed. And then once we kind of got through the general information for each subbasin, then we looked with Google Earth imagery and mapped out these polygons for every subwatershed. And so what you see, the table on the left just illustrates that this is Neal Creek, like between river mile 5.7 to 5.6, and this polygon has a score, ended up with a score of 36, because it did a pretty good job of addressing limiting factors. And I should say that each of these polygons or opportunities had a whole list of restoration actions. And the more restoration actions for a given polygon, the better the score, because those things were addressing more limiting factors. So For this project, it addressed limiting factors well, and it had did a fairly good job of mitigating climate change, kind of moderate. And it was, the actions improved natural processes, and so that yielded a total benefit score of 36. And so when mapping these polygons, we really looked at what the highest scoring projects were. So we generated these maps that, and I'll skip to the next one, that only show polygons that are high priority. So this is the lower East Fork of the Hood River subbasin, split in half, so I could zoom in a little bit. So you can kind of see here's where Baldwin Creek comes in to the East Fork Hood River. And the polygon shape is affected by the 100-year floodplain width. And so you can really see along a lot of lower East Fork, it's got a pretty broad 100-year floodplain. And that coincides with a lot of restoration opportunities because as long as you don't flood infrastructure, houses or roads, it's really good for fish to do habitat restoration in these areas. Okay, so Alex, would you unmute and tell me how much background noise you can hear?
It's not bad.
Okay. Okay, so moving on to the theory of change, which a large group of people spent quite a bit of time developing this theory of change. I'm just gonna do a broad brush approach to that. But the strategies that we settled on for, addressing the primary limiting factors and threats are these 6, and they're restoring and protecting stream and floodplain habitat, increasing and protecting summer stream flow, managing forest and roads to support normal hydrologic function, restoring fish passage, improving water quality, and engaging the community. So I'm going to highlight a few of these and show you what the theory of change ended up looking like for a few of these strategies. So, we have a suite of actions, some of which, we've been talking about, I've been talking about for the last 20 minutes, and outputs are sort of the units that, these actions would be expressed as. And then we've got the ecological outcomes over here in the far right columns. So shorter term ecological outcomes and longer term ecological outcomes. And so for restoring and protecting stream and floodplain, adding large wood, also removing berms and decommissioning roads in floodplains to improve that stream floodplain interaction. And then in some cases, creating favorable conditions for beaver in key locations. And I think a good example is a project that we're working on right now where on Neal Creek, where there is a beaver and or there's beaver sign. I don't know if it's one or more, but there's also a nearby orchard. And so there is a conflict between beaver and orchards if beaver go into the orchards and sharpen their teeth on the trees. And so, in that situation, we're looking into whether we can do some fencing to keep the beaver in the riparian corridor and out of the orchard, because beaver can be incredibly beneficial for stream habitat. And they're managers of the floodplain, so they're there all the time and fine tuning things and keeping fish habitat in those situations in really good shape. Strategy 2, I wanted to highlight a couple of actions that haven't been noted yet, and that is, we know how important on-farm irrigation is, but there doesn't seem to be as rapid of interest or rapid of conversion as, you know, as we would like to be able to sort of achieve optimal water conservation in the next 20 years. So we've been talking about a barrier assessment to on-farm irrigation upgrades and sort of an interview approach to see, you know, are there things that we as partners can be helping with to, you know, remove barriers to make it easier for farmers to upgrade their systems. We've also talked about identifying the remaining parcels with inefficient irrigation equipment so that makes that outreach more efficient. And then, of course, continuing to provide technical and financial assistance to farmers for on-farm irrigation upgrades. Something I haven't talked about yet, another thing is we may need as a partnership and a basin to explore alternative irrigation water sources, and whether that's groundwater or, you know, maybe in 20 years a new reservoir off channel. That's a very expensive and challenging endeavor, but you know, when we look out farther, you know, into the future, if the glaciers completely go away, the stream flows are going to really drop, and so we need to be looking out far enough into the future to prepare for that. And last but not least, engaging the community and continuing to give presentations, promoting efficient technology, making sure that our communication is accessible to, you know, both in English and in Spanish, telling stories of success, hosting stream neighborhood gatherings, and something that I would like to do is develop a homeowner guide to water conservation, something that's really targeted towards residential landowners. Okay, almost at the end, folks. So just a few slides left. And so another thing that OWEB is having us do, and I think is a really great approach, is monitoring of outcomes to measure our progress and inform future work. So, you know, adaptive management. So this is just an example, and this is something that's still under review and discussion. But when we place large wood in streams, we've got some implementation objectives, sort of the key, some of the high priority subbasins: Neal Creek, Main Stem Hood River, Lower East Fork Hood River. We have a certain number of miles of stream and side channel that we're targeting, and the way that we'll track it, and this is something actually that ODF&W, Jim Brick, who's with us this evening, he tracks this for all of the watersheds in the Lower Columbia, you know, in his region of the Lower Columbia, looking at the length of stream treated with large wood. There are certain aspects of that treatment that, you know, you need to have at least 5 key pieces, and you have to have a certain volume per 100 meters of stream, length of side channels reconnected. But then what is the ecological response that we're hoping to see? What kind of metric, what can we go out there and measure to know that what we are aiming to do is really happening? So one of the things large wood does is it creates more pools. So going out and measuring pools before and then several years after a project can get at, and the Warm Springs tribe has done some of this monitoring before and has shown an increase in pools from restoration projects to date. Pool depth, maybe macroinvertebrate abundance. That's something that I'm kind of particularly interested in. And also looking at stream substrate. So the D50 is sort of the 50% piece of substrate that is, I guess that's it's sort of the median substrate size for a given, you know, reach of a stream. And when you have a high D50, that means you've got bigger material, big cobble or maybe boulder, and that is not as ideal for spawning habitat. And so adding wood, we would expect that the stream bed material would start to shift slightly in its size, in its average size. So looking on average at substrate, and also what does the substrate look like right at the downstream end of pools where salmon and steelhead spawn. So that's just an example of what we're looking into. And then, as far as adaptive management, meeting every year and reviewing what the partners have been finding from project effectiveness or, other kinds of monitoring that we're doing. How do projects go? And have an opportunity each year to check in. All right. This is also needing to be verified. Most of this is pretty solid, but what is the total cost of most of these projects? And so on-farm irrigation efficiency, 8,000 acres, about 4 million a CFS. And so for 23 CFS, or I think maybe that's supposed to be 21 CFS, it's about $9 million of funding, and that's sort of cost share funding provided to farmers to upgrade their systems. And note that it's 0.4 million per CFS. And I'm sorry, I did not do the math after Holly and I met. I think I didn't. Anyway, this is a lot higher. This is a certain number of, this is probably, this might be 3 million. I think there's about 3 million per CFS, because we think that it's going to be about 21 CFS saved times 3 million. That gets us to the 63 million. So, 6 times as expensive to get the same CFS savings. No doubt we'll still be doing it, but I think it really underscores just how important the on-farm upgrades are. In-stream habitat is also no slouch in the cost department. Coming in, if we do 30 miles, it's probably about $12 million. I have a little bit less certainty over the side channel restoration, but I think it's probably somewhat comparable to the main channel. And then riparian habitat restoration. This 15 miles comes from, and all of these actually, so ODF&W has targeted a certain amount of habitat restoration to accomplish to support recovery. And so that's what these miles are based off of. 30 miles is what a little, it's in the ballpark a little bit more than what ODF&W thinks perhaps we have left to really help reach recovery. So that's it. And sorry, I went a bit over. On the bright side, we hardly have any business. So I think we'll still gotta get done early. But I just wanted to, end by thanking everyone that's been involved in this. You can see the long list. Probably half of you who are here tonight are on here. So I just appreciate working with everybody. It's been quite a process. So with that, I think I will take any questions that people might have. I'll open.
Cindy, I was just curious, how do we prioritize the work if we have close to $100 million worth of work to do? How do we prioritize, or do we just go for it with, attack it on all fronts and get what we can get? Or is there some other way that we say this is the highest priority, we should do this first and do all of it, or do pieces and parts, you know what I mean?
Yeah, that's I'm glad you asked that question. So I think that, and when you add all of that up, it's pretty daunting. A huge chunk of that is East Fork irrigation district, upgrades. Is Steve still on the line, or did he get did he get scared off?
I'm still here.
Yeah, all right, good. So I think that, I think we have to, kind of look at each realm separately, because, that funding source, very fortunately, as you know, Farmers Conservation Alliance and Holly, when she was working with them on East Fork's plan, they're eligible for federal funding, and 63 million is it may cost that. I'm personally hoping it doesn't cost quite that much, but it is possible that East Fork could get pretty close to that with the combination of federal and state funding. It really depends, on, I think, what the federal government decides to invest in infrastructure across the country. So when you think about, then, that's the other, that sort of still leaves, 40 million or 30 million. And that, it is 20 years. So, but in terms of prioritizing, yes. So for the stream habitat restoration, there are some really important basins that, and certain polygons, have more bang for the buck in terms of habitat value. But at the same time, I don't think we should put for stream habitat restoration, I don't think we should put all our eggs in one basket. I think that the Neal Creek and the lower East Fork Hood River baskets are pretty important right now. I think doing a little bit more in the upper West Fork, for example, could be warranted. But yes, we are focusing within the basin in the areas that we think are the best bang for the buck. And we need to, look for a wider diversity of funding sources. And that is a part, I haven't mapped it out as far as like, well, if we, for 20 years, if we brought in these different funding sources, we could get 80% of the way. I haven't done that yet. I can speculate.
So are there any other questions, comments? How do people feel about it
Yeah.
in terms of being comprehensive, and does it seem doable? Does, is something missing? We're not going to add anything more. It's
Yeah.
Well, I think some of the stuff like you talked about with the irrigation upgrades, I mean, that's what we work on a lot. So that's what I'm really familiar with. But the barriers assessment and, doing a assessment of where the upgrades are already. And so that could really help kind of make a prioritization for what the most important areas might be. And then if we identify barriers, obviously, then we'll know whether we're ever going to get them all done or not. But also just like, maybe we can say these ones are much higher priority than these, or whatever the case. So I think having that as kind of a first goal is good, because then it's not as like daunting, because we, even if we, if we had money to do that much per year, it's still, getting it all done and everything. So
I think that's the most, I think getting the money for all of the East Fork upgrades is certainly daunting. But in terms of sort of amount of person power, within the partnership, I do think that the on-farm irrigation is the most aspirational, because I think, we're not anywhere close to 400 acres a year right now.
Mhm.
At least that people that are receiving funding. And I think would be interesting to know, Jordan, I don't know whether you have a feel for this at all, but how many farmers are just doing it on their own? Because if half of them are doing it on their own every year, then maybe it's not as yeah. So
I don't have a good feel for it, but I certainly there's a chunk that do. Maybe like Bryant Pipe or somebody could give you a better estimate of how many people are going through them.
Yeah.
Yeah, I was just like, I want to always make in these plans, like what will like totally fix everything, and then what's like feasible and realistic to do and accomplish in 20 years, and they're not necessarily always the same thing.
Yeah, I know. I agree that 400 acres a year is definitely a big step up, big increase in rate from what I understand. So, whether that's realistic, I mean, it just depends on, who works on it, if multiple partners work on it, and there's sufficient funding, that the technical aspects of it, or the feasibility aspects of it, are certainly important. That was really more coming from what we could cut that back. I mean, you basically, it's scalable. You see how many CFS, we know pretty well how many CFS get saved, and we know also, with based on all of the the work that's been done by the SWCD and IRRANET, how much savings there is. It's a staggering amount and benefit for these on-farm projects. It's such a great bang for the buck.
Mm-hmm. Yeah, definitely.
But the SWCD can't do it by itself.
No.
Right.
Well, not at current capacity anyway.
No, right. Yeah. So I mean, it's not a one partner show, that's for sure. It would have to take more concerted effort, more money. So the plan's just really meant to show the potential and the the goal and objectives. I think that the stream habitat restoration is pretty doable. 30 miles in 20 years is about 1.5 miles a year, and that's basically 2 projects a year. So logistically, that's not too bad.
Jim, did you have a question?
I was just going to make a comment that I think that what I saw today is really a solid plan that you guys have put together over the last 3 years. I've worked on a number of these, and basically it takes everything you've done in the last few years and put it all into one document, and it kind of shows the breadth and need of what needs to be done in Hood River to kind of turn the page a little bit and prepare for the future. And I think the concept behind these OWEB capacity FIP grants is, all right, show us what you need to do, and maybe, we can throw bigger block grants together to help you kind of chip away at that a little bit faster. And I think you definitely achieved that from what I saw as part of the presentation today. And I think it's really a great product, and I congratulate you on finishing it or coming close to finishing it.
Thanks, Jim. Yeah.
Yeah. Anybody else have a question or comment?
Yeah, Chuck, can you hear me now?
Yep.
Well, as a participant on various committees, clear back to the vision statement and then strategic action planning, I recognized a lot of what we did in those individual meetings. So it's good to see that work was fruitful, and I'm glad I stayed awake during those meetings, because it looks like, you're there. It's a good plan. That Cindy did a good job of presenting it. The only thing I would say is try to get maybe a little more concrete on projects when it comes down to funding, and, you know, when somebody's going to spend money on something, you know, instead of abstract and really broad, maybe try to narrow it down a little more if possible, so that it makes sense for, and as a fisherman, you know, I'm always about, you know, more fish in the river, and that's what the grant's purpose is supposed to be, wild fish at least. But, you know, if yeah, I'm not a strictly a wild fish guy, I'm more of a hatchery proponent, honestly. And my personal opinion is that the Hood River is ideally suited for hatchery production. And it was that way during the 70s and 80s, during the heyday of summer steelhead production. And if you talk to the people in Hood River, they still remember those couple decades. And it's kind of sad because we've lost that. We don't have that anymore. You don't, kids growing up now don't even know what they missed because they don't have it, and they never have that. But if we can keep improving even on wild fish production, I have a little bit of hope there. So, I mean, I realize it'll probably be never as good as fishing as it was when I was in junior high and high school, but even if
Hey,
we
Greg,
can just
hey,
improve.
Greg, in terms
Yeah.
of specificity on projects, this was the high level look at it so that we could all stay awake for the presentation. I have seen what Cindy's written at, and there is tons of specificity in terms of mile by mile
Yeah,
or
the
all
technical.
those stream things. So yeah, there's a lot of, you know, this was just to kind of explain the whole thing and give good example of the overarching goals and the methods. So that's definitely there.
Yeah, it's the condensed version. I know you can put all that in a one and a half hour presentation,
Right.
maybe
Yeah.
a one and a half year presentation, maybe.
Yeah, that you guys wouldn't stay, nobody'd be around for that.
Cindy, you didn't talk as fast as you said you would.
Um,
You could have gone faster.
Really? I'm a little tired probably.
Cindy, did you see the question from Smita?
Yeah, and I think Lisa had her hand raised, and then
Okay.
I'll read off Smita's question.
All right.
Lisa, did you want to unmute? Oh,
Yeah, are you able to hear me now?
Yes.
Okay, yeah, sorry about that earlier. I was curious, I appreciated your piece on monitoring outcomes, and I know that's still in development with your metrics, and I'm just curious about your funding sources for the effectiveness metrics. Are those going to be linked to project, kind of at the project level and through separate grants, or is
I think it'll be a
goal?
mixture. Yeah, I think it'll
Okay.
be a mixture of sources. For restoration projects, you can tack on some money to do project effectiveness monitoring from quite a few funding sources. OWEB definitely, but then there's a lot of monitoring that happens in the basin that the tribes and ODF&W have been doing for 20 years, and that data is, some of that data is summarized in the action plan. And so they're using funds in both those cases. They're using funds from Bonneville Power Administration, basically money that they have earmarked to run their programs in the hood.
Okay, yeah, thank you.
Yeah. And then Smita, you wanted me to talk about the 6 CFS, potential 6 CFS from residential conservation, and which streams it would benefit. So, and Megan, be curious, maybe I do need to talk with you and Les about the number. I mean, Les has mentioned on many occasions that a lot of the water that FID diverts is going to residential water use. I mean, I'm an FID customer, and to irrigate, my half-acre, of garden, etc. And I definitely have had, heard comments from various partners about the sort of the, even, and, Middle Fork, Craig and John, I know you've said it as well, that the relative application, per acre on residential land is a lot higher, likely a lot higher than a well-managed orchard. And so even though there's a lot more orchard land than residential land, where I came up with this 6 CFS is I looked in the water use assessment that Nicholas did. So for each irrigation district, the estimate that the irrigation district managers gave for the amount going to residential. And it was a little different for each, how each district manager described it. But I came up with about, and then I added the 2 CFS from the city of Hood River. So it was 16 CFS based on the water use assessment, 16 CFS from farmers, 14 CFS from East Fork, and 2 CFS from the city of Hood River. And so those are numbers that are highlighted in red in the report that I need to verify with you guys. But so let's just say it's 32 CFS and we get a 20, so 20% of 32 CFS is 6 CFS, pretty sure. And so where is that going to have the most benefit? Well, a little bit will be up at Lake Branch from the city of Hood River's diversion. Farmers is on, the main canal. The main diversion serves a lot of the residential use, and then East Fork diverts sort of, has its one main diversion. So it is in a few different places, Smita. Yeah.
Okay. Time-wise, we probably should move on unless someone has a pressing question. You better shout it out now.
So I'll just close with if anybody thinks that at some point over the next year there are other organizations or groups in the community that would like some version of this action plan presented to them, let me know. And then of course, I'm around and I'm sure I'll be talking with quite a few of you about details of this. So yeah, and let's see. If you're not part of the sort of the list of names that's been involved in the action plan development and you want to look at the draft, also let me know. I can send it, I can give you access to it before it's finalized.
Okay, so I'd like everybody to unmute and we'll have our round of applause for Cindy for the presentation. So thank you very much, Cindy. Great job. All right. Let's see. Can we just take a 2-minute break here? People might need to stretch or whatever. So we'll come back and move on. We don't have a lot of business, but we'll come back and carry on and try and get out of here by our 8 o'clock timeline. So 2 minutes.